Thank you, everyone, for coming to this post-lunch session. I know it's a tough one. We are here to give our talk about the pivotal RabbitMQ for Kubernetes, which is in closed beta as of SpringOne. So if you would like access to it, please, we will link to the sign-up form toward the end. So I'm Zoe Vance. I'm product lead of messaging at Pivotal. I've been working with Pivotal for about 3 years with the commercial RabbitMQ teams.
And hello, I'm Chunyi. I'm the tech lead for the RabbitMQ on Kate's team.
Great. So in this talk, we're going to talk about the pivotal RabbitMQ for Kubernetes product. We're going to talk quickly about RabbitMQ, just for those of you who maybe have not used it recently. We're going to talk briefly about Kubernetes and then about how we're bringing them together, as well as the technical architecture for the product that we have announced today. We're then going to talk about where the product currently is, what are the enterprise features that we have in it at the minute, and what were some of the complexities in implementing those features on Kubernetes, and then we're going to talk about the roadmap. So first of all, pivotal RabbitMQ for Kubernetes. So with the product, what we're trying to achieve is provide the best operational RabbitMQ experience we can by leveraging those native Kubernetes components. And that means we're using the operator pattern to automate and manage deployment and upgrades. Oh, sorry, I thought there was something else. Currently, the product today uses RabbitMQ 3.8, which is new as of last week. I highly recommend you check it out. There are some great new features. It supports PKS and other Kubernetes flavors. It integrates with Pivotal Platform via the service broker, all of which we'll talk about a little bit more in a couple minutes. So for those of you, just briefly, for what is RabbitMQ? It's a long-running open source project written in Erlang, backed by Pivotal. It's a general-purpose message broker based around queues that has a smart broker passive consumer model, implements AMQP, and has also AMQP 0.9 and has support for a wide range of other protocols, so MQTT, Stomp, and others. Has wide and extendable support as well for different client libraries and plugins, both those that ship natively with the product as well as those contributed by the community. And it's used in a wide range of applications. So when we talk to customers, they're using it for event-driven microservices, RPC, ETL with Spring Cloud Dataflow, as an enterprise message bus, pub subs, real-time analytics with Reactor and the RabbitMQ Reactive API. So it's used quite widely. So why do people use RabbitMQ? This is a tweet I encountered recently. It's extremely mature and stable. It's been around for about 10 plus years. This tweet is talking about having had it in production for almost 3 years and just the experience that has given them. It has really strong built-in management and monitoring. So the management and admin console ships natively with it. This is actually a screenshot from the new 3.8 monitoring capabilities, which have built-in graphs with Grafana that you can leverage. You can see here, you can see your queues, the consumers, connections, channels. We did have a link to a live dashboard here, but it actually felt a little too risky mid-talk. So other reasons people use RabbitMQ is really powerful routing capabilities. It's easy to scale, can be configured for a broad range of application needs. So consistency, high availability, low latency, or high throughput. It's very easy to get started and developer friendly. Brief architectural screenshot here. You can see that you have the producers that are sending messages to the RabbitMQ broker, to the exchanges in the broker, and this is some of the routing flexibility that we talked about earlier. The exchanges route messages to FIFO queues, although you can add priority to your messages if you'd like. RabbitMQ will send an acknowledgement to the producer if you so wish to ensure that if there's failure between the producer and the broker, that message is not lost. The consumers will maintain persistent TCP connections with RabbitMQ and declare which queues they consume. And RabbitMQ, the broker, will push messages to those consumers. Consumers can, again, acknowledge success or failure, and messages are removed from queues once successfully consumed. All right, Chunyi.
And before we dive into the products that we have built for RabbitMQ running on Kubernetes, let's have a brief overview of Kubernetes first. So container-based workloads have changed the way that development and operation teams test and deploy softwares. It has helped companies modernize their processes on shipping softwares by making it easier to scale and deploy applications. But at the same time, it has also introduced all kinds of new challenges, and this is where Kubernetes comes into the picture. So Kubernetes is an open-sourced container orchestration system. It is designed to help you automate running and managing your containers. Because of its extensibility, you can also see it as a framework for declarative APIs and distributed controls in general. It has grown popularity in the last few years, and it is now considered the standard container orchestration system in our industry. So why is it so popular? Why are people using it, and what are the benefits of using Kubernetes? One of the benefits being able to is basically like you can increase the velocity of your application development teams. Application developers can see faster feedback loops developing on Kubernetes, since updating, patching, deploying workloads as containers is faster than dealing with virtual machines, which will enable continuously developing and releasing new features for your end users. Secondly is the portability. Kubernetes is cloud agnostic. You can deploy yourself on bare metal, public clouds, or on-prem, or any kind of ISs that you have on hand. Or just choose from any cloud-managed Kubernetes offerings, from Google or Azure, any of those offered Kubernetes. This means that your software does not need to be updated when you're running it on different clouds. And that's a huge benefit. Lastly is the cost efficiency. All your workloads running in containers in Kubernetes, and workloads can be co-located onto the same machines without impacting each other. This means that tasks from multiple teams, multiple developers can be packed tightly onto fewer machines, and therefore achieve a greater cost efficiency on hardware compared to virtual machines. So how does Kubernetes work?
Chunyi, do you want to just try holding it a little closer to your mouth? There's a little bit of an echo.
So how does Kubernetes work? First, Kubernetes is a declarative system, which is great for reproducible deployments. Users declare the desired state of their workloads and applications running in the cluster. Kubernetes will then compare the desired state of those workloads and applications, which are, again, inputs from users, to the desired state. Once it has noticed any differences between the application actual to its desired state, it will perform various actions to correct the situation. This means that it has self-healing ability. The check between the desired and the actual state is performed continuously by Kubernetes. And after achieving the desired state, Kubernetes will still constantly take actions to ensure that the system stays that way as time passes by. This check between the actual and the desired state is done by various Kubernetes controllers. Controllers are Kubernetes components that keep watching the state of all kinds of resources in the cluster and make necessary changes to move the actual states towards its desired state. And I will use one particular controller as an example of how it works. So imagine that you have created an application and with just one pod running your application. And by the way, pod is an atomic scheduling, deployment, and runtime for a group of containers in Kubernetes. Containers that are deployed in the same pod can generally share file systems or networkings, etc. So your application is receiving much more traffic than you have expected. And now you want to scale up the number of pods to 3 instead of 1. You can use kubectl, which is the Kubernetes CLI, to apply a new version of your application manifest. One of the controllers in Kubernetes is going to receive this request. In this case, it's the replica set controller. It sees that compared to the desired state of your application, there are 2 pods missing, and is a little bit unhappy. So now it's going to create 2 more pods to adjust the actual state to the desired state. And now everybody's happy because we achieved the desired state for your application. So we have just covered an example where the replica set controller scales up the number of pods. Kubernetes comes with a collection of built-in controllers that manage standard Kubernetes resources, like the stateful set controllers, pod controller, services controller, etc., etc. Those controllers run in the control plane of Kubernetes and are basically unaware of each other. Because of this architecture, we can extend the Kubernetes API by plugging in our own controller. So now I'll move into the technical architecture. So the way of extending Kubernetes API by plugging in your own controller that we talked about in previous slide is called the operator pattern. It is introduced by CoreOS, and basically you define a custom resource definition that represents your own resource, and in this case is a RabbitMQ instance. And also you write a controller that knows how to reconcile the desired state and the actual state of the custom resource we have defined. With your own custom controllers, you keep them running as separate resources, just like any other Kubernetes controller we saw in the previous slides. And together with a custom resource definition of a RabbitMQ instance, Kubernetes can now manage RabbitMQ like any other standard resources. You can now ask Kubernetes to schedule and maintain a RabbitMQ instance just like creating a standard resource, like a pod. And now I'm going to move on to a recording of a demo of our product before talk a little bit more on the technical architecture. So on the right side of the screen, you can see that we're targeting a Kubernetes cluster, which already have our RabbitMQ operator and the service broker installed. We're just using kubectl, which is the Kubernetes CLI, to list all the namespaces that the cluster has. On the left side, you see this beautiful Apps Manager UI, which is connected to a Pivotal Cloud Foundry. So I'm going to start the demo. You can see that we're going to a specific org and space. And now we're trying to see all the available services and trying to create a RabbitMQ service instance in this specific space. And there are two plans available. For the sake of demo, we're using single, which means that you just get one node of Rabbit in your RabbitMQ. Okay, and then now we're providing the names for our service instance. And after that, just click Create. This basically means that we are now creating a RabbitMQ instance in the Kubernetes cluster that we are looking at on the right side of the screen. And if you see carefully, there's a new namespace that has popped up in the list of namespaces that we have there already. And that is the namespace where the RabbitMQ instance is going to be created in. So now we move to the terminal, and we're targeting that particular namespace where we have our RabbitMQ instance. And the next step, we are going to list all the pods that the namespace has. You can see that there's a RabbitMQ instance, RabbitMQ pod in that namespace because we chose the single plan. And then we can also inspect the logs from that particular RabbitMQ server. Yes. As you can see here, the server has successfully started it, and from the start, we have implemented all kinds of plugins just out of the box. So we have like federations, management, and shovel, all of that good stuff. Yeah. So that's the end of the demo. So as shown in our demo previously, creating a RabbitMQ instance was very easy. Application developers or anybody can basically just click that button in the Apps Manager to do that. And this is because we have also developed a service broker alongside with our RabbitMQ operator. The RabbitMQ service broker we have developed is going to be responsible for creating and deleting RabbitMQ instances. Our service broker follows the Open Service Broker API model, which is an API model that allows independent software vendors and app developers to easily provide backing services to workload running on different platforms, such as Kubernetes, and in our demo's example is the Cloud Foundry. This API provides a simple abstraction of provisioning and deprovisioning service instances. So when you're using a RabbitMQ service broker, the application developers doesn't need to have access to the Kubernetes cluster to be able to provision a RabbitMQ instance. And in fact, they don't even have to know that the RabbitMQ instance is being created and run as a container in Kubernetes cluster. And just to illustrate that idea a little bit more, in the demo, it was our RabbitMQ service instance was created by clicking a button in the beautiful UI of Apps Manager. If you're not using Apps Manager, you can also use CF CLI to do that. So you can do CF create service, and this is going to provision a service instance. And depends on what kind of service broker, what kind of service you're trying to provision. It can be creating a VM, creating a database, or creating a RabbitMQ instance behind the scene. Application developers doesn't really need to know all of that details. Another thing that you can do is you can do CF bind service, and what this would do is that the service broker would then do all the necessary things to come back with necessary credentials, so that you can have an application that is created in Pivotal Application Service to be able to access that backing service you have just provisioned. So let's talk a little bit more of what happened in the demo. So first, you will need to have RabbitMQ Service Broker and the operator installed in your Kubernetes cluster. And then you register our broker, just like registering any other service broker that you have with your Cloud Foundry. You can then run CF create service, and basically just like provisioning any other service instance. The broker then take the request and see which plan and configuration you have chosen and generate a corresponding RabbitMQ manifest. It then uploads that manifest to the Kubernetes API, and then the rest is basically taken care of by the RabbitMQ operator. It receives the request and will create that RabbitMQ instance for you. And in the case of trying to bind that backing service, that backing RabbitMQ service, you can run CF bind service. And the service broker then take the request and will retrieve necessary credentials from the Kubernetes API and then pass it back to your application that is running in Pivotal Application Service. And after that, basically, your application that is deployed in Pivotal Application Service can now connect to RabbitMQ that is deployed in Kubernetes cluster. And now I will pass it back to Zoe, and then she's going to talk about some enterprise features we have included in our product.
Great. So for the beta that we're announcing, we have a current state features here. As you saw in the demo, we had 2 plans that we're offering with it right now. You have a single node deployment, which allows you to deploy a single node, very helpful for development or lightweight test use cases. We also allow you to deploy what was called in the demo an HA plan. It's a 3-node cluster. Again, if there's node failure, the cluster will continue to operate. We've implemented persistence, so if you want to persist your messages to disk, you can do that. Again, in case of failure, you have those messages there. These are some of the production requirements that we see frequently and wanted to make sure we included early. As Chunyi went over, we have the service broker for Pivotal Platform integration, which abstracts a lot of the complexity of Kubernetes away from your developers. And we have integration with Prometheus, in part to take advantage of some of the 3.8 functionality. And as Chunyi also mentioned, we've enabled a bunch of the most common plugin requests that we get and the most used plugins we see day in, day out. We just actually finished a consistent installation experience deploying as a CNAB bundle. So now we're going to talk through a couple of the challenges that we had integrating some of these features and how we've tackled that so far and what our next steps are on implementing and building with Kubernetes. So the first here is high availability. This is obviously hard in Kubernetes. The reason why we wanted to ensure that we had this is that it's quite a common feature needed in production. It lets you build lets your applications continue to operate even under node failure. And we've also, sorry, I got a little confused there. We've also, I'm going to mention that in a moment. So the challenges in Kubernetes here are that pods can be rescheduled for a variety of reasons. And when pods share worker nodes with other pods, a pod might get bumped or rescheduled if there's a constrained resource. The other challenge here is that stateful clustering recovery is known to be challenging in Kubernetes. This can either happen because there's an issue with RabbitMQ or due to the underlying Kubernetes cluster. So in the current beta, we've implemented clustering, partly using the RabbitMQ peer discovery plugin. We've also enabled federation shoveling plugins. And the reason we've put that under high availability is because it lets you move and replicate messages across other brokers. So if you want to be building active-active or active-passive topologies with the beta, that you can achieve that with the current swath we've taken. There are next steps that we do want to do here to address some of those challenges in Kubernetes that we see. So the primary one is to leverage pods affinity and anti-affinity rules. And that will allow us, as well as the disruption budget, that lets us specify the minimum number of nodes that will need to be online so that we can ensure the uptime that's needed. We're also going to be testing for failure scenarios and making sure that we can recover and we understand the different ways in which we'll recover for both Rabbit failures and underlying Kubernetes failures. So as I mentioned before, we also have implemented persistence, so making sure that messages are not lost if they're persisted. The challenge in Kubernetes here is complexity in how stateful clusters are managed and brought back after downtime. Currently in the beta, we have used Kubernetes native components to implement persistence. And what we've done is the disk that we're using is not elastic though, so the next step we want to do is elastic persistence, so automatically expanding storage if we do run close to that limit. One of the Kubernetes challenges here is also that the disk attached to pods can be disassociated when a pod goes down. This isn't particularly challenging Kubernetes, but the other thing that we prioritized, as we mentioned, was observability. Again, a graph of the 3.8 work. And currently, we are shipping RabbitMQ 3.8, as well as that Prometheus and Grafana integration. So looking forward at the roadmap, we're currently looking at automated upgrades. We've had a lot of meetings, actually, in the last week about the different components that need to be upgraded here. So the broker, the operator, the Rabbit custom resources, as well as the cluster instances. After that, we're going to be looking at hardening security there, as well as testing the scaling limits of how many Rabbits we can be running on a single Kubernetes cluster, as well as additional configurations. So you saw earlier that we had those two plans, the single node and the HA plan. When we were talking about Rabbit in the beginning, we talked about a lot of its extendability and flexibility to support a wide range of use cases. We want to make sure that we unlock that power in future iterations, as well as finally disaster recovery. Of course, this may all change. If you have strong thoughts, please get in touch. And if you want further links, we have the Rabbit for Kubernetes alpha blog that went up. We have the beta sign-up form, as well as feel free to come up to us afterward and we can get you access to the closed beta if you would like it, to try it out. There's resources that we've added here that were helpful on the Kubernetes operator pattern, as well as the Rabbit 3.8 release notes, which we alluded to a few times. And thank you to everyone who helped us with this talk. That's all we have for you. Thank you so much.